In section 5.2, we're going to start by looking at some basic probability rules. So let's just define some terms. The sample space is the set of all possible outcomes of a chance process. For example, if you roll a die, the sample space would be 1, 2, 3, 4, 5, or 6, because those are the possible outcomes. If you flip a coin, the sample space would be heads or tails. A probability model then takes the sample space and assigns a probability for each outcome. So for example, for the coin, we would have heads and tails and then 0.5 for each one of them. So this would be the possible outcomes, and this would be the probability. So I have an example here of a probability distribution for randomly chosen covenant exam scores from 2007 to 2016. So if I randomly picked a student from one of those years, this would be the probability that they scored each of the following scores on the AP exam. So the sample space are the scores, which are 1 through 5. Those are the only possible scores. And then the probabilities are assigned for each score was received. So this is a probability model. And the next term to define is event. An event is any subset of the sample space. So for example, in the die model, what is the probability? We could say event A is rolling an even number. Or for the coin, we could say event A is getting ahead when you flip a coin. So here we're going to define event A as a student scored a 5. Event B as the student passed the exam. So this is how we write the probability. The probability that a student passed the exam, or the probability of event B, would be the probability that they scored a 3 or a 4 or a 5. So this is probability of 3 or 4 or 5. So I just add up those probabilities. 0.312 plus 0.297 plus 0.205. which would be 0.814 or 81.4%. The probability that a student did not score a 5, or the probability of not event A, which we can write as A complement with a little c as a superscript there, would be this. We could add up the scores from 1 through 4, so that would be the probability of 1 plus 2 plus 3 plus 4, or we could say, since the total probability that they'll get one or more of these, the total probability of getting a score on the AP exam is 100%. So we could say 100% minus 5%, the scores for a 5, or 1 minus 0.205, and that would be 0.795. So a 79.5% chance that they did not score a 5. Here's another way to list a sample space. So here we have a sample space for rolling 2 dice. So this would be rolling the first dice and then the second dice and so you see ordered pairs representing the first roll and the second roll. Notice that rolling a 1 and a 2 and rolling a 2 and a 1 are two different events in this case, because order matters in this sample space. Each of these events is equally likely to occur, and we have 36 different possible outcomes. Now, if I wanted to make a probability model for the sum of 2 dice, first I would list the possible sums. So the possible sums would be my sample space. So my sample space in this case would be the numbers 2 through 12, because those are the possible sums of rolling 2 dice. So if I list my outcomes, it would be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Then if I list the probability of each outcome, then I would have what's called a probability model. So the probability of rolling a 1, or a sum of 2, is 1 out of 36. We would also have a 1 out of 36 chance of rolling a 12. For 3, it would be these two values right here, 1 and 2 and 2 and 3, so we have a 2 out of 36 chance. For 3, it would be 1, 3, 2, 2, and 3, 1, or a 3 out of 36 chance of rolling a 4. For rolling a 5, we would have these 4 different ways to roll a 5. and so on. We could keep completing this table. The most likely thing is rolling a 7 because you can do 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, or 1, 6. So that's 6 out of 36. And then it goes back down. 5 out of 36 chance for an 8, 4 out of 36 for a 9, 3 out of 36 for a 10, and 2 out of 36 for 11. Now the total is going to be 36 out of 36 because there is a 100% chance that you will roll one of these sums. Okay, so the total probabilities in the sample space must add up to 1. When we have equally likely outcomes, all we have to do is count the number of ways something can occur, the desired outcome, over the total number of outcomes. So in this case, since all of these pairs that you could roll are equally likely, what's the probability of rolling doubles? Well, there's 6 different ways to roll doubles, 1, 1, 2, 2, 3, 3, etc. So the probability is just 6 out of 36. The probability to get a sum out of 4, we've already seen, is 3 out of 36. Now let's just summarize some of our basic probability rules before we go on. The probability is always a number from 0 to 1. 0 means it can't happen. 1 means it will always happen. The probability of all the possible outcomes, or the sample space, always has a sum of 1, because when you add up all the probabilities of all the different outcomes, it has to add up to 100%. If all outcomes are equally likely, the probability for event A is the number of ways event A can occur divided by the number of possible outcomes. So, for example, the probability of doubles equals the number of ways to get doubles in rolling a dice all over the number of ways to roll 2 dice, which is 36. The complement rule says the probability that not A will occur, that A will not occur, which could be symbolized A complement, is just 1 minus the probability that A will occur. And then we learned if we have the probability of A or B occurring, we could just add the probability of A plus the probability of B. Now this is only true if the events are mutually exclusive. So we need to define what is meant by mutually exclusive. Mutually exclusive events are considered, 2 events A and B are considered mutually exclusive or disjoint. Those are synonymous terms if they cannot both occur at the same time. So, for example, are rolling doubles and rolling a 4 mutually exclusive? Well, the answer is no, because there is one outcome that they have in common. 2, 2 is rolling doubles and rolling a 4. Okay? An example that would be mutually exclusive, however, would be if A equals rolling doubles and B equals rolling a 7. Because there are no, so these are mutually exclusive because they have no outcomes in common. No roll can be in both groups. Doubles will always give you a sum of an even number. There's no way to use doubles to get a 7.